In the intro to bond section, I talked about the bond valuations that are on page 18. And so what we're going to go over now is the answers to the items on page 18. At this point, if you haven't answered these, you're much better hitting pause, go through, figure them out, answer them, and then watch how they're solved. If you're just going to jump from one to the other and not actually do the work, what's going to happen is it's not going to sink into your brain. When we end up going to an exam, it's just going to blow right over the top of you, and you're not going to get it. All right, so on page 18, what we have here is we have a bond that's $25,000 with a 10% coupon rate that's maturing in 30 years. Now, we have three questions because we have three rate environments. First rate environment is 5%. Second rate environment is 8%. And the last one is 12%. So now what we need to do is to solve that valuation. The first thing that we need to do in solving valuation is we're going to take the coupon rate times the face value. And that's going to give us our interest per year. So that's going to be $2,500. Now, once you have the coupon rate and you multiply the coupon rate times face value, you no longer need coupon rate. In fact, a lot of people, like I said in the previous video, they are going to use this as the rate environment, and what you're going to figure out is that a $25,000 bond that yields 10% in a 10% environment is worth $25,000. But like we talked about before, interest rates go up, interest rates go down, the value of stocks go up and down every day, the value of bonds go up and down every day. And bond valuation moves with interest rate in what's called an inverse relationship. Right? We covered that last time. Inverse means opposite. If interest rates go down, the value of bonds go up. So what we can tell at this one, if we got a 10% coupon rate, if interest rates fall to 5%, one thing I know for sure about this answer, before I even figured out anything, it's got to be above $25,000. In 1B, interest rates have fallen to 8%, and so since value is inversely related, this one's going to be worth above $25,000 also, but because 8% is above 5%, this one is going to be actually worth less than 1A. A 12% interest rate, the interest rate is above the coupon rate, so my answer here is going to end up lower than $25,000. So if we work this through, we're going to take our 5A, we're going to take $25,000, which is our bond face value, and we get that value back in 30 years. So we're going to multiply that times the present value of $1. And then I get my interest payments. So I get $2,500 every year. And since I'm getting it every year, it's an annuity. So I'm using present value of an annuity. In our 8% one, these stay the same. Right? No matter what happens to interest rate, face value stays the same, interest rate stays the same. So when we're doing this calculation, all three of these are going to be the same number. All right? And we're going to multiply across here present value of $1, present value of an annuity, present value of $1, and present value of an annuity. All right, so now what I'm going to do here is fill in my factors using n of 30 and my different interest rates. So I'm going to have a different factor for each one because I have a different interest rate. Although n stays the same for everything because my bond is 30 years. So on the first one, you can take the present value of $1 times 2.2314, and 2,500 times present value of an annuity, K equals 5, N equals 30, gives us a factor of 15.3725. 25,000 times the present value of $1, using an interest rate of 8%, because that's the interest rate environment, and of 30, gets us an amount of 0.0994, and present value of an annuity, 11.2578. So as you can see here, interest rates are going up. Our multipliers here are going down, which is going to create a lower value when we add these, or when we multiply these across. The last one here, present value of $1, K equals 12, N equals 30, gets us a factor of 0.0334, and our present value of an annuity factor is 8.0552. Then what we're going to do is we're going to now multiply these across. Okay, now we're going to multiply these factors through. Okay, so on the first one, we're going to get 5,785 and 38,431 for a total value. We add the two together because if you're buying the bond, you get the interest payment and you get the annuity. 44,216. All right. So we're going on here. $25,000 times present value of $1. K equals 5. Don't use K equals 10. K equals 5. N equals 30 is a factor of 0.2314. Total of $5,785. The interest payment is an annuity. We get $2,500 every single year. If the interest rate environment's 5, N equals 30, present value of an annuity, we get 15.3725, means 38,431. So this bond is worth $44,216. So this bond sells at a significant premium. Premium, once again, is that the value of the bond is above face value. So we say that's a premium. When we calculate the second one here, interest rates went up. So when interest rates go up, the value is going to go down. So I'm going to erase this one here. Otherwise, we're going to be way too smashed on valuations. So in this one, now present value of $1, 25,000, one lump sum payment. Interest rate is 8%, N equals 30, is 0.0994. And we multiply that across, it gets us 2,485 for the value of the face value. And the annuity, we get 28,145. We add those together for a total value of our bond of 30,630. This is still selling at a premium, right? It's still above $25,000, and we're at a premium because the current interest rate environment is lower than coupon value. So we get a total value of 30,630. When we do our last one here, one thing I know for sure before I even do this, I'm going to end up with a value under 25,000. And the reason I'm going to be under 25,000 is the interest rate is above the coupon rate. And so since values move in opposite direction, it moved above 10,000, so the value is going to move opposite, value is going to come down. So we multiply that one across. We got 0.0334. Gives us a value of only $835. The value of the annuity, 2,500 times 8.0552, gives us 20,138 for a total bond value of 20,973. This bond sells at what we call a discount, because it sells for below face value. And that's the end of question 1. Okay, now let's take a look at question 2. So now we have another bond with a $100,000 face value. So this is obviously a pretty big bond. The coupon rate is 7%, and it matures in 10 years. The first thing we do is we calculate the interest each year. 7% times 100,000 gets us $7,000 in interest payments, and we're going to get that for 10 years. And then we're going to get our $100,000 back out here 10 years from now also. So if we look at these valuations and we look at K, on question number A, our interest rate environment is 6%. In question 2B, our interest rate is 9%. And in question 2C, our interest rate is 10%. So when this bond was first issued, current rates were probably around 7%. That's why it was issued at 7%. Then interest rates move, right? They might have gone up, they might have gone down. They move every day. So we're going to use current interest rate environment. And once again, once we take coupon rate, time face value, we no longer use coupon rate. I've said it like 27 times, but I guarantee you, usually somewhere between 5 and 10% of the class uses this number instead of using these in the current interest rate environment, and they get the wrong answer. I don't want you to be one of those. So what we're going to do is we've got the two things that we're getting. Once again, each bond always, or the bond always pays $7,000 in interest. That's fixed. You're always going to get back your face value at maturity, your $100,000. To figure out the value, we're going to take, since we're getting our interest every single year, that's present value of an annuity. Lump sum, present value of $1. Our annuity, present value of an annuity, present value of $1. Present value of an annuity, present value of $1. Then we're going to look up the factors using K at 6, 9, and 10. So what I want to do is I want to look up present value of an annuity, K equals 6, N equals 10 to get my factor. And when I look that up, I find that that is 7.3601. My present value of $1 factor, 0.5584. I'm going to do the same thing here at 9%. So I look up my 9% numbers. My annuity is 6.4177. My lump sum number is 0.4224. And my last one, my annuity factor is 6.1446. And the lump sum number is 0.3855. Okay, so now what we're going to do is we're going to multiply these across so that we can get total values. All right. So we're going to get, on the first one, on the lump sum, $55,840, and on our annuity, $51,520, for a total value of $107,360. Now, since the interest rate is lower than the coupon rate, we knew this was going to be worth more than $100,000, and it is $107,000. When we calculate this one through, 9% is above 7, so we're going to be under $100,000. So I'll erase this so that we're not smashed in, which we already probably are. And 2B, we look at the annuity here. That's worth 44,924, and the lump sum is worth 42,240 for a total value of 87,164. All right. So interest rates are going up, 6% to 9%, values coming down. The last one, k equals 10, we should see a value, once again, that comes in lower, below 87,164, if we're doing everything right. If we get a different number than that, or certainly if I get a number above $100,000, I got to go back and figure out where I made my mistake. So, question C, 7,000 times 6.1446 gets us a value of 43,012, and our lump sum gets us a value of 38,550 for a total bond value of 81,562.